Yes, ready?
I think so.
Okay, we close the account here.
Yeah.
Test for hydrogen.
What?
Hydrogen.
Oh, you put a lighted splint in the test tube, and if it pops, it's hydrogen.
Test for oxygen.
You put like, what is it, like, not semi-lighted? I forgot. Like glowing splint.
Glowing
splint in the test tube, and it relights.
Good. Test for chlorine.
Chlorine, it bleaches litmus paper.
Yes, very good. Test for ammonia.
I think it's something to do with litmus paper. I think I forgot the color.
And is
red.
Ammonia is
red.
Ammonia is acidic or alkaline or basic?
Oh, alkaline. So red to blue.
Good.
Yeah, okay. Okay.
That's for carbon dioxide.
Carbon dioxide. You pump it through lime water, and
yes.
It has white precipitate.
Yes.
Yep.
Test for sulfur dioxide.
Aqueous, acidic potassium manganate. There we go.
Manganate.
Potassium manganate, and it turns from purple to colorless.
Very good. Yeah. Then test for water vapor.
Oh, I forgot the substance, but it turns into a crystal. A blue crystal.
Anhydrous copper 2 sulfate. Anhydrous means.
Anhydrous. Okay.
Anhydrous means dry. Anhydrous means does not contain water.
Okay. Okay. So it's just copper sulfate. Okay.
Then it will turn to blue crystal, and that blue crystal is hydrated copper. Hydrated copper sulfate means it contains water. Yes.
Yeah.
And it will stick to 5H2. Then they form crystal.
Yeah.
Yeah. Good. All sulfate are soluble except for 3. What are they?
Iodine, I think. Right, no.
Barium, calcium, and lead.
Barium, calcium, and lead.
Okay, the solubility table I'm going to. Okay, never mind. Later I send you. But this thing, you must be able to memorize all this reaction. Okay. Now this one. Anions.
Yep.
Anions have 6. OH minus, CO3 2 minus, NO3 minus, Cl minus. CO3 2 minus. What are the names here?
Hydroxide.
Very good. CO3 2 minus.
Carbonate.
Very good. NO3 minus.
Nitrate.
Very good. Cl minus.
Just chlorine.
Chloride.
Chloride.
Chlorine is Cl2 gas. This is anion. It's dissolved in the solution, and it's colorless. Yeah.
Okay. Chloride. Okay.
SO4 2 minus.
I don't remember.
Sulfate.
Sulfate. Oh.
This is the one that I just asked.
Yeah.
All sulfate are soluble except
chromium, calcium,
and lead.
What?
Lead.
Wait, again?
Tb. Lead. Barium,
yeah, say the
calcium,
three again.
barium,
calcium, and lead.
calcium,
Okay.
and lead. Da,
Okay.
Ca, and Pd. Yeah.
Yep.
I minus here.
Iodine.
Iodide.
Iodide.
Iodine is I2. Yeah.
Yep.
And I2 is a black solid. This is aqueous solution, and it's colorless. Yeah. The OH minus is hydroxide.
Yep.
OH minus is easy to detect. If it contains OH minus, means is acidic or alkaline.
Alkaline.
Which means if you put red
Litmus paper, turns blue.
Yes.
Okay.
Okay. Carbonate. Carbonate is CO3 2 minus. If you react with any acid, it will produce.
What?
It will produce something. Reaction pattern number 2.
I don't remember.
Acid plus carbonate. What will we get?
Carbon dioxide.
Carbon dioxide.
And salt.
And salt. And water.
And water. Okay.
And water. Salt is it's difficult for you to see. Water also is already water everywhere, so you cannot see also.
Okay.
So, but you can see the bubbles of carbon dioxide.
Oh, okay. Yeah.
Okay. So if you're given an unknown substance and you suspect that there is carbonate inside, what you do? You add any acid. Any acid you put
any acid. Yeah.
Then what will you see?
Bubbles.
Bubbles.
From the carbon dioxide.
From the carbon dioxide.
Okay.
Yeah. Must be something that is obvious. Obvious to see. Yeah.
Yeah.
Nitrate. Nitrate, I think we look at this notes here. See? Yeah. These notes. NO3 minus. How to test? You add sodium hydroxide, NaOH. Then you add aluminum foil.
Oh.
Aluminum foil, the one that's for cooking.
Yeah.
Then you heat it up. Then you will produce bubbles of ammonia.
Where's the aluminum foil?
Where's the aluminum foil? It will dissolve.
So it's inside the
solution.
The
it
solution.
Will disappear.
Okay.
And you don't see it anymore.
Okay.
Like it disappear. Yeah.
Wow.
Okay. Sodium hydroxide is solution, colorless solution. Aluminum foil looks like silver. Shiny. Shiny. It's not silver, but it looks like silver.
Yeah.
Then ammonia. Then you produce ammonia.
Okay.
And you can tell by the smell. It's pungent smell.
Okay.
Then the ammonia you still must, to confirm the ammonia, you must test using
the litmus paper.
Good. Color change from
red to blue.
Very good. Because ammonia is
an alkaline.
Very good. Yeah.
Yeah.
Okay. So remember the carbonate. To test for carbonate, you add acid. Then you get effervescence. Oh, they call it effervescence. Effervescence means bubble.
Oh, okay.
I don't know. They like to use that word. Effervescence of carbon dioxide produce.
Okay.
Test for Cl minus. You must acidify with nitric acid. And what is nitric acid? HNO3. Yeah.
Yep.
Then you add aqueous silver nitrate. Then you will see white precipitate.
Okay.
This is pattern number 5, precipitate reaction. We are going after memorizing this, we are going to learn the reaction. Yeah.
Okay.
But
Yeah.
to test for Cl minus, you add silver nitrate. What is silver nitrate? AgNO3. Yeah.
Okay.
And what will you get?
Yellow precipitate. Oh, okay.
White.
Silver.
AgCl plus
Yep.
NO3 minus. And AgCl is white PPT.
White. Oh, okay.
You will see it at the bottom of the test tube.
Mm-hmm.
Small white precipitate there.
Okay.
Okay. Test for iodide, similar. You add nitric acid, then you add silver nitrate. That means I minus plus AgNO3. Then you get AgI
Mm-hmm.
plus NO3 minus. And this AgI is yellow precipitate.
Okay.
Okay.
Mm-hmm.
One last one to test for sulfate.
Mm-hmm.
Test for sulfate, you acidify with nitric acid, then add barium nitrate.
Okay.
Then you get white precipitate. That white precipitate is barium sulfate. Barium nitrate like this. Okay.
Okay. What about the nitric acid?
Oh, the nitric acid do nothing, but we need it to clear up the carbonates, because the carbonates are white precipitate.
Yeah.
It might confuse you. You will see, because because they're in water.
Mm-hmm.
You might have some carbonate. Then this carbonate also, if you wait for a long time, then you will see white precipitate at the bottom.
Oh, okay.
Then it might confuse you. So the HNO3 is to remove that.
Okay.
Okay.
Yeah.
It's still confusing, but it's okay. Really, this topic is, we need to revise many times. Yeah.
Mm-hmm.
Because confusing.
Yeah.
So we have 6 OH minus. How to test?
I don't remember.
Acidic or alkaline?
Oh, litmus paper. It's
Yes.
alkaline. Yeah.
Then
from red to blue.
Good. You put the litmus paper to solution.
Yeah.
Okay. Carbonate.
Oh, you add any acid, and then it becomes carbon dioxide, water, and yeah.
The salt.
Salt.
You're going to have effervescence of carbon dioxide.
Okay. Effervescence.
Then the carbon dioxide itself, you must test using
the lime water.
Very good. Lime water. Yeah?
Yep.
And what will happen? What will you observe?
White precipitate.
Very good.
Yeah.
Test for nitrate. How do you test for nitrate?
I don't remember.
You add small piece of something from your kitchen.
Aluminium and
Aluminium
barium?
foil? No.
Or I thought I remember something like that.
Okay. Okay. Memorize for 3 minutes. Yes.
That's so hard. There's so many complicated.
You'll get used to it. Because I'm going to keep asking you.
Sodium hydroxide. Okay.
Yes, ready.
Okay, I hope.
Okay, it goes.
Okay.
That's for hydroxide.
Hydroxide is the litmus paper. It turns from red to blue.
Carbonate.
Carbonate is you add any acid and it becomes it bubbles with carbon dioxide.
Very good. That's for nitrate.
The aluminium one, I think. You use sodium hydroxide and aluminium, and then ammonia is produced.
Very good.
Which has a bad smell.
Good.
Okay.
The best for chloride.
Chloride, you acidify it with nitric acid, and then you add Silver. Aqueous silver, I think.
Silver nitrate.
Silver nitrate. Yeah. And then it turns white. The white precipitate.
Yeah, produce white precipitate.
Okay.
Very good. As for iodide.
Iodide is acidified with the nitric acid, and then the same thing, silver nitrate.
Good.
But then the precipitate is yellow.
Very good.
Okay.
As for sulfate.
Sulfate is acidified with nitric acid, and then add barium nitrate.
Yes.
Okay, and then white precipitate.
Very good. That's for carbon dioxide.
You pump it in lime water, and there's a white precipitate.
Very good. That's for sulfur dioxide.
I think it's that one is like the aqueous potassium magnate, and it's from purple to colorless.
Very good. Yeah.
Yeah.
That's for chlorine.
Chlorine, it bleaches litmus paper.
Very good. Wow. See? Wow, you memorize. You can memorize. Actually, I already write on this way. Yeah? See? Sulfate plus barium nitrate.
Yeah.
Okay. Wow. Okay. Now for the most complicated one are the cations. The cations have 9.
9. Okay.
H plus is easy. Can you tell? Can you guess how to?
Hydrogen.
No, not hydrogen. H plus. Oh, hydrogen ions can. Yeah, hydrogen ions. How
is
to
it
test?
an alkaline? So then.
Acidic.
Oh, sorry. Oh yeah, H. Yeah, H is acidic. Yeah.
Yeah, acidic. Yeah. How to test?
So it goes from litmus paper.
Yeah, litmus paper. Yeah.
From blue to red.
Yes. Good.
Okay.
Okay. NH4 plus is ammonium. It's not a gas. Is a cation. Is aqueous solution.
Okay.
How to test? You add a strong base. Any strong base.
Yeah.
And usually they use sodium hydroxide.
Yeah.
And this is pattern number 4 on our list of chem reaction.
Okay.
Base plus ammonium. What will you get? What will you get?
I don't remember.
Salt and water and ammonia.
Oh, salt, water, and ammonium. Like the ammonium gas.
Ammonia gas.
Ammonia gas. Okay.
Ammonium is this thing. Ammonium is the cation.
Okay.
Yeah. So ammonium something plus sodium hydroxide, then you get salt plus water plus
ammonia.
Ammonia.
But if you heat up ammonium, will it become a gas?
Yes, if you really heat it up. But you will produce very little.
Oh, okay. So ammonium is not the form of ammonia. It's two different things.
Ammonium is slightly acidic. This is ammonia.
Yeah.
Ammonia have two forms, either ammonia gas or aqueous ammonia.
Oh, okay.
Both of them are ammonia, but this thing is a gas. This is aqueous.
Okay.
Then you have ammonium, NH4 plus.
Oh, NH4. Okay.
This thing is weak base.
Okay.
This NH4 plus here is a weak acid.
Okay. Oh. Okay.
Why is it a weak acid? For example, NH4Cl. This NH4Cl is made up of NH3
and hydrogen.
HCl.
Hydrogen chloride. Okay.
So that's why you have NH4Cl. And this is a weak base, and this is a strong acid.
Yep.
After you combine, then it will be slightly acidic because it's made up from weak base and strong acid.
Strong acid. Okay.
Yes.
I think, yeah. Okay.
And somehow this NH4 plus is aqueous.
Okay.
Solution. Yeah.
Yep. Yep.
Okay. That's why NH4 plus can react with sodium hydroxide because it's slightly acidic.
Okay.
That means it can react with base. This test is similar to here, test for nitrate.
Yep.
Because test for nitrate also you use sodium.
The sodium sodium hydroxide.
Right. The difference here, the nitrate, to test for nitrate, you must add one more thing. What is it?
Aluminium
Foil. Aluminium foil.
Aluminium foil. Yeah.
This one is sodium hydroxide without aluminium foil.
Okay.
It will produce the same thing, ammonia also.
Okay.
Yes.
Oh, yeah.
Yeah, similar. Don't get confused. So the one that needs aluminium foil is test for nitrate. The one that doesn't need is the ammonium.
Ammonium. Okay.
Okay. Yeah, I have cough. You know what happens? The 2 weeks, no, last week. Last week I get COVID.
Really?
Yeah.
Oh, wow.
It's not
Was
too
it
bad,
bad?
but
Oh.
it's not that bad. And just take the medicine every day, then finish. Just but I sleep a lot. Yeah. Okay, this one. Yeah.
Yep.
Fe2 plus.
Okay.
How to test? You add sodium hydroxide.
Okay.
You have a solution and you suspect that it contains Fe2 plus. To confirm that it contains Fe2 plus, you add sodium hydroxide, then you will get a reddish brown precipitate. And that reddish brown precipitate is FeOH2. That's it. Fe2 plus.
Yep.
Plus 2 NaOH. It is. Then you get FeOH2. Plus 2 Na plus. This is reddish brown precipitate.
Okay.
Yeah. That's how to test. If it is Fe2 plus, it's similar. By the way, from 3 to 9, you're adding sodium hydroxide, so it's easy to memorize. Yeah.
All of them?
So all of them, you add sodium to test. You add sodium hydroxide.
Isn't it 2 to 9? Because NH4 plus is also sodium hydroxide.
Oh yeah, 2 to 9. Yeah, 2 to 9.
Okay.
Oh, but from 3 to 9, you're going to get precipitate.
Ah, all right.
Yeah. Number 2, you produce gas instead.
Gas.
Yes.
Yep.
Yeah.
Okay.
Okay. This one, FeG plus, you add sodium hydroxide, then you get green precipitate.
Okay.
Number 5 is CO2 plus, you add sodium hydroxide. You get blue precipitate.
Okay.
So you must memorize the color. Reddish brown is Fe2 plus.
Yep.
Green is FeG plus. Blue is CO2 plus.
Yep.
And you add sodium hydroxide or aqueous ammonia.
Okay.
That means the reaction like this. 2NH3 plus 2H2O. You're going to get FeOH2 plus 2NH4 plus. Like this.
Okay. So you need water as well?
Yes.
Okay.
No, the water must be there because the sodium hydroxide is aqueous solution also.
Yeah.
Yeah, which means it's already contain a lot of water.
Okay.
Yeah, understand. The sodium hydroxide that you use is aqueous, which means have a lot of water.
Okay. Yeah.
So to test number 3, 4, 5, you either use NH3 or sodium hydroxide.
Okay.
Then you get the same result: reddish brown precipitate, green precipitate, and blue precipitate. Except for the CO2 plus.
Oh.
CO2 plus is a little bit complicated. CO2 plus, if you put inside sodium hydroxide, you get blue precipitate insoluble in excess. What does it mean by insoluble in excess? You have a solution, you suspect contains CO2 plus, you add sodium hydroxide, you get light blue precipitate. You keep adding sodium hydroxide, the light blue precipitate stays.
Okay, so it can't solute back. Okay.
Yeah. If you add aqueous ammonia, you get light blue precipitate soluble in excess, giving a dark blue solution. Means the light blue precipitate, it will disappear. Then the whole solution turn dark blue.
Okay.
How about this one? Fe2 plus and FeG plus. Reddish brown precipitate and green precipitate. Both of them are insoluble in excess.
Insoluble. Okay.
Yeah.
Yeah.
See, getting more complicated. Okay.
Okay.
Now, this thing. 6 to 9 is more difficult because you add sodium hydroxide. All of them give white.
Okay.
So you cannot tell them apart.
Yeah.
But actually you can tell them apart. Yeah. First of all, Ca2 plus is easy to detect. Ca2 plus only white precipitate only with sodium hydroxide. It doesn't produce white precipitate with ammonia.
Oh, okay. I see. Yeah.
Ca2 plus sodium hydroxide, you get white. Ca2 plus aqueous ammonia
NH3. Yeah.
doesn't work.
Okay.
The other three, 7, 8, 9, zinc, aluminum, and lead, it will produce white precipitate for both.
Okay. Yeah.
Yes.
Yeah.
Okay. So number Ca2 plus you can detect. We still have problem with zinc, aluminum, and lead. We cannot tell them apart.
Yep.
Zinc we can tell. Zinc is soluble in excess sodium hydroxide and aqueous ammonia to give colorless solution.
Okay.
These two is soluble in excess sodium hydroxide only, but insoluble in excess ammonia. These two.
Okay.
Yes.
Yeah.
Zinc hydroxide with sodium, zinc 2 plus with sodium hydroxide, you get white PPT soluble in excess.
So if you put more zinc, it'll disappear again.
If you put more sodium hydroxide.
Oh, I see. Okay.
If you put more sodium hydroxide, it will disappear. Then it's colorless solution again.
Okay. Yeah.
The same thing with zinc with ammonia.
Okay. Yeah.
White precipitate, then you add excess ammonia, then it will disappear again.
So you have to have the right amount of sodium hydroxide
to see the white precipitate. That means
when
you put it, you must put it very slowly.
Slowly. Oh, okay.
Very little, and then you see white.
Okay.
Otherwise, if you put too much, then you never see the white precipitate. You just repeating this up again.
Yeah. Okay.
Yeah, that's why you see that. Okay. Okay. But this thing, Al3 plus and Pb2 plus, is soluble in excess sodium hydroxide, but insoluble, you still see white precipitate in excess ammonia.
Yeah. Okay.
So this way, you can tell the zinc apart.
Yeah.
But still have problem. You cannot tell the difference between Al2 plus and Pb2 plus.
Yeah.
And how to tell them apart is not on the official note, but I know.
Okay.
Not only me, a lot of people know also, but it's unofficial. Okay. You add Ki, potassium iodide.
Okay.
Ki is to provide the I minus. Yeah.
Okay.
Then Al3 plus with Ki, you get colorless solution. You see nothing, as if there is no reaction. There's no reaction.
Okay. Yeah.
Pb2 plus Ki, you get PbI2, which is yellow.
Okay. So the first one, you don't know if the reaction happened or not?
Yeah, that means it doesn't happen. You put a lot of Ki, nothing happen for Al3 plus.
Okay. Okay.
For Pb2 plus, slowly you add, then you will see yellow.
Okay.
Yes.
Yeah.
9. Then please memorize at home. This 9. Then next lesson I will test you one by one, and the solubility table also. Yeah.
Okay.
Solubility table and reactivity series. You forget reactivity series, that means you're going to get, and they don't give you the list on the exam. They don't give you solubility table. The one that they give you is only the periodic table.
Okay.
Only the periodic table. They don't give you the solubility table. They don't give you the reactivity series. Yes.
Yeah.
Do memorize as much as you can. Then we test, and it's going to be a little bit complicated because so many combination. But we do it open book for we are going to do exercises like this. Yeah.
Yeah.
But it's open book. Yeah.
Okay.
Until you're ready, then close book.
Okay.
Last question for today. Test for sulfur dioxide.
Sulfur dioxide is you add aqueous potassium magnate, and then it becomes from purple to colorless.
Good. Good.
Thank you.
Bye.